Dr. Jun Kim stood at the huge glass window of the transport ship, staring at the Galactic Research Institute for the first time. The building floated in space like a giant silver snowflake, with 6 arms stretching out from a central hub. Tiny lights sparkled along each arm, showing where thousands of the galaxy's smartest beings worked and lived. Jun took a deep breath. After years of study and hard work, he was finally here. Earth had chosen him as their newest math expert to join the institute. His hand shook a little as he gripped his worn leather bag tighter. "First time at the institute?" asked a friendly voice beside him. Jun turned to see a human woman with short black hair and kind eyes. She wore the blue uniform of institute staff with 3 silver stars on her collar. "Yes," Jun replied, trying to hide his nervousness. "I'm Dr. Jun Kim, Earth's new math representative." "Dr. Hannah Park," she said, holding out her hand. "I've been here 3 years. I'll be your guide for the first few weeks." Jun shook her hand, feeling relieved. "Thank you. I wasn't sure if there would be other humans here." Hannah smiled. "There are about 30 of us now, out of nearly 10,000 beings. We're a small group, but we work hard." The ship docked with a gentle bump. Jun followed Hannah through the airlock and into the institute. The main hall was enormous, with a ceiling that seemed to reach up forever. Beings of all shapes and sizes moved about. Some floated, some crawled, some had too many limbs to count. Jun tried not to stare. "It's okay to look," Hannah said quietly. "They're all looking at you too. Humans are still new to the galactic community." As they walked to the human living area, Hannah explained how things worked at the institute. Each species has their own living space designed for their needs. We all share workspaces and the common areas like the cafeteria and libraries. She stopped walking and turned to face Jun. Her expression grew serious. "I should warn you about something. You'll face some challenges here that aren't about math." "What do you mean?" Jun asked. "Many species here can naturally see or sense 4 dimensions. Some can perceive even more. They think humans are limited because we only naturally perceive 3 dimensions. Jun frowned. "But that doesn't change the math. Numbers work the same no matter how many dimensions you can see." Hannah gave him a sad smile. "That's what I thought too. But it's hard to compete when others can visualize complex dimensional problems in their minds while we have to work through them step by step." She started walking again. "Just be prepared. Some of the aliens aren't very nice about it." The next morning, Jun joined all the new arrivals in the central chamber for orientation. The room was shaped like a perfect sphere, with seats rising up on all sides. Beings of all types filled the seats, chatting in dozens of different languages that Jun's translator turned into English in his ear. A tall, thin alien with skin that glowed like moonlight floated to the center of the room. Everyone grew quiet. "Welcome, new members," the being said, its voice soft but clear. "I am Advisor Tal, director of the Institute. We are honored to have such brilliant minds join us." Tal's glow brightened as it spoke about the Institute's mission to solve the greatest puzzles in the universe. Jun listened carefully, taking notes on his tablet. "Now," Tal said, "I am excited to announce this year's grand challenge." The room buzzed with excitement. Hannah had explained that each year, the Institute chose one major unsolved problem for everyone to work on. For centuries, the Penrose-Vex theorem has remained unsolved. Tal continued. "This theorem, if proven, would revolutionize our understanding of spacetime and allow for huge advances in faster-than-light travel." A hologram appeared in the center of the room, showing shapes and equations that twisted in ways that hurt Jun's eyes to look at. "The problem requires new approaches to 5-dimensional topology," Tal explained. "We have assembled the finest minds from across the galaxy. The species that solves this problem will receive triple research funding for the next 50 years and recognition throughout the galaxy." Jun looked around and saw many aliens nodding confidently. Some were already discussing ideas with their neighbors. But when he glanced at the other humans in the room, he saw worried looks. After the meeting, June joined the human team in their assigned lab. There were 5 other mathematicians, including Hannah and an older woman who introduced herself as Dr. Soo-Jin Kang, the human team leader. "This is bad," Soo-Jin said bluntly. "Very bad. The Penrose-Fex theorem is exactly the kind of problem humans struggle with. It requires working with objects in 5 dimensions. A young man with glasses sighed loudly. "We might as well give up now. The Axiom Collective can perceive 6 dimensions naturally. How can we compete with that?" "We don't give up," Hannah said firmly. "Humans have solved hard problems before without being able to see what we're working with. We built tools, we found different ways to understand." Soo-Jin looked unconvinced. "We'll try, of course. But don't expect miracles." That night, Jun couldn't sleep. His mind kept spinning with equations and shapes that he couldn't quite picture. After hours of tossing and turning, he gave up and decided to get some coffee. The Institute's cafeteria never closed. When June arrived, only a few beings were there, sitting far apart at different tables. The food stations offered meals for all types of biology, but June was relieved to find a simple coffee machine in the human section. As he waited for his coffee, he noticed someone cleaning the tables. It was another human, a man with strong arms and a kind face. He looked to be in his 50s, with gray starting to show in his black hair. "Can't sleep?" the man asked in Korean, surprising June. "No," Jun replied in the same language. "Too many new things to think about." The man nodded. "First week is always the hardest. I'm Dae-ho Lee." "Jun Kim. Are you on the math team too?" Dae-ho laughed. No, I'm just a custodian here. I keep things clean and fix things that break. I was a carpenter on Earth before I came here." Jun was confused. How does a carpenter end up working at the Galactic Research Institute? "Long story," Dae-ho said with a smile. "But the short version is that my daughter, Minji, is a xenobiologist here. I came to be close to her after my wife died." He gestured to the coffee pot. "That's ready now." Jun poured himself a cup, and on impulse, got one for Dae-ho too. They sat at a table together. "So, what's keeping you up?" Dae-ho asked, sipping his coffee. Before he knew it, Jun was explaining the Penrose-Fex theorem and the challenge it presented. He used sugar packets and napkins to show the basic concept of dimensional topology. "The problem is that we need to work with objects in 5 dimensions," Jun explained. "But humans can only see in 3 dimensions. We can use math to describe higher dimensions, but we can't visualize them the way many alien species can." Dae-ho listened carefully, his eyes focused on the sugar packets Jun had arranged. "When I built houses," he said slowly, "I often couldn't see the whole structure at once, but I could understand it through the blueprints, and by building it piece by piece." He picked up one of the napkins Jun had been drawing on. "Maybe you don't need to see all 5 dimensions at once to understand them." Jun blinked. "What do you mean?" "Just thinking out loud," Dae-ho said with a shrug. "I'm not a mathematician. But in my work, sometimes understanding the connections between things is more important than seeing everything at once." They talked for another hour, with Jun explaining more about his work and Dae-ho sharing stories about his life. By the time Jun returned to his room, his mind felt clearer, though the problem was no closer to being solved. The next few weeks were intense. The human team worked long hours, trying different approaches to the theorem. Jun found himself staying late every night, often alone in the lab after the others had gone to sleep. One night, as he stared at equations that seemed to blur together, Hannah came into the lab. "You need rest, Jun," she said gently. "Working until you drop won't solve this." Jun rubbed his eyes. "I know, but I feel like I'm missing something obvious." The Axiom Collective already announced they've made major progress. "They have 6-dimensional perception," Hannah reminded him. "Of course they're making progress. But there must be a way for us to approach this differently," Jun insisted. "Just because we can't see in 5 dimensions doesn't mean we can't understand them." Hannah sat down beside him. "That's what I've been trying to tell everyone. We need to find the human way to solve this. What's the human way? June asked. I don't know yet, Hannah admitted. But throughout history, humans have faced limitations and found ways around them. We couldn't fly, so we built planes. We couldn't see atoms, so we built microscopes. We always find tools to extend our abilities. Before June could respond, his tablet chimed with a message. It was from Advisor Tall, requesting a meeting with the human team the next morning. That can't be good, Hannah said, reading over his shoulder. June's stomach tightened with worry. Do you think they're going to remove us from the challenge? I don't know, but we better be ready to defend our place here. The meeting room was small, with just a round table and chairs. Advisor Tail sat across from the human team, its glow dimmed to a soft blue light. I wanted to check on your progress, Tal said. Some other teams have expressed concerns about the human team's ability to contribute to this particular challenge. Su Jin straightened her shoulders. We are making progress, Advisor. It's slower than some teams, yes, but we're exploring new approaches. With respect, Tal said gently, the Penrose-Vex theorem requires working in 5 dimensions. Many feel this puts your species at a natural disadvantage. June felt anger rising in his chest. Before he could stop himself, he spoke up. Every species has advantages and disadvantages, Advisor. Just because we can't naturally perceive 5 dimensions doesn't mean we can't understand them mathematically. Tail turned its glowing eyes to June. An interesting perspective, Dr. Kim. But mathematics at this level isn't just about equations. It's about intuition, about seeing connections. Humans have intuition too, June insisted. We just develop it differently. Throughout our history, we found ways to understand what we cannot directly perceive. The advisor was quiet for a moment. You have 6 more weeks before the first evaluation. Show me this human approach you speak of, Dr. Kim. I would be pleased to be proven wrong in my concerns. After Tal left, Su Jin turned to June with a frown. That was bold. Now we need to deliver on your promises. June's confidence wavered. We will. We have to. But as he walked back to the lab, he wondered how they would ever compete with beings who could naturally see what humans could only describe with equations. He needed a new approach, something uniquely human. That night, he returned to the cafeteria, hoping to find Dao. Something about talking with the carpenter had helped clear his mind before. Maybe it would help again. Sure enough, Dao was there, mopping the floor. When he saw June, he smiled and set his mop aside. More math problems, he asked. More than I know what to do with, June admitted. They got coffee and sat down at what was becoming their regular table. This time, June brought his tablet filled with equations. I don't expect you to understand all this, June said. I just need to talk it through with someone who isn't already stuck in the same thought patterns as the rest of the math team. Dao nodded. Sometimes fresh eyes see things differently. Tell me about your problem. As June explained, Dao listened quietly, occasionally asking simple but surprisingly insightful questions. Something about explaining the complex math in plain language helped June see aspects of the problem he'd been missing. You know, Dao said after a while, this reminds me of shadow puppets. Shadow puppets? June was confused. Yes. When my daughter was little, I used to make shadow animals on the wall. A simple hand shape creates a complex shadow. The shadow is just a projection of the real object into a lower dimension. June stared at him. Projection. That's it. What's it? Dao asked. Maybe we don't need to see in 5 dimensions. Maybe we just need to understand how 5-dimensional objects project into spaces we can understand. June's mind was racing now. It's like, if a 4-dimensional object passes through our 3-dimensional space, we see a series of 3-dimensional slices of it. He grabbed a napkin and began drawing frantically. We could develop a mathematical framework that lets us understand 5-dimensional topology through its projections and relationships without needing to visualize the whole thing at once. Daeho smiled, clearly not following the math, but pleased to see Jun excited. So my shadow puppets helped. More than you know, Jun said, still scribbling equations. This could be our human approach, not trying to see what we can't see, but finding ways to understand it anyway. For the first time since arriving at the Institute, Jun felt real hope. He might have found the beginnings of a path forward, a uniquely human way to solve a problem that seemed impossible. The next morning, Jun rushed to the human team's lab. His mind had been racing all night with new ideas after his talk with Daeho. When he arrived, Hana and Sujin were already there, looking at 3D models on the main screen. I think I have something, Jun said, slightly out of breath. He pulled out the napkins he had covered with equations last night. Sujin raised an eyebrow. You wrote our solution on napkins. Not the solution yet, Jun explained, but maybe a new way to approach the problem. He spread the napkins on the table and began explaining his idea about projections. Think of it like shadows, he said. We can't see a 5D object directly, but we can understand it by looking at how it casts shadows into lower dimensions. Hana leaned forward, interested, like how a 3D cube casts a 2D square shadow on a wall. Exactly. Jun nodded eagerly. We don't need to see all 5 dimensions at once. We just need to understand the relationships between these projections. Sujin looked skeptical. This is basic dimensional math, Jun. Everyone knows about projections. Yes, but we've been trying to extend our 3D thinking upward, Jun argued. What if instead we look at multiple projections simultaneously and build a framework to understand the relationships between them? The team spent the morning discussing Jun's idea. Some were doubtful, but Hana supported him. It's worth trying, she said. Our current approach isn't getting us anywhere. By lunchtime, they had divided into 2 groups. Sujin would continue with the traditional approach, while Jun and Hana would explore the projection theory. As days passed, Jun and Hana worked long hours developing their new method. They created a system to map 5D objects through multiple 3D projections, each showing different aspects of the higher dimensional shape. It's like looking at a building from different angles, Jun explained to the other humans. No single view shows everything, but together they give you a complete understanding. One evening, when most of the team had left, Jun was still working. He had filled the lab's whiteboard with equations and was stuck on a particularly difficult part of the problem. The math wasn't working out. The door opened, and to his surprise, Daeho walked in with cleaning supplies. Still working? Daeho asked. It's very late. Jun sighed and rubbed his tired eyes. I can't figure this part out. The math gets too complex when we try to relate these different projections. Daeho set down his cleaning cart and looked at the whiteboard. Though he couldn't understand the advanced math, he watched Jun point to different parts of the equations. You know, Daeho said after a while, this reminds me of wood joints. Wood joints? Jun was confused. Daeho nodded. In carpentry, when you join pieces of wood, you need to understand how they fit together from all angles. Sometimes, the connection looks simple from one view, but complex from another. He pulled a napkin from his pocket and began folding it. Let me show you something. Daeho folded the napkin into an intricate pattern. Then he held it under the lab's light, casting a shadow on the table. See this shadow? He said. Now watch what happens when I rotate it slightly. As he turned the folded napkin, the shadow changed shape dramatically. The object is the same, Daeho explained. Only your view of it changes, but if you understand how the object rotates, you can predict what each shadow will look like. Jun stared at the changing shadow, his mind racing. That's it. We don't need to model the entire 5D object. We need to understand the transformation rules between different 3D projections. He grabbed a marker and began writing new equations on the whiteboard. If we can define the mathematical relationships that govern how a 5D object transforms as it's projected into different 3D spaces, Daeho smiled. I don't understand your math, but I'm glad my napkin helped. More than helped, Jum said, still writing frantically. This could be the breakthrough we needed. The next day, Jun showed his new approach to the team. He brought Daho's folded napkin and demonstrated the shadow principle. We've been thinking about this wrong, Jun explained. We don't need to try to see in 5D. We need a mathematical framework that describes the relationships between multiple 3D projections of a 5D object. Su-jin frowned. And how does a folded napkin prove this will work for the Penrose-Fex theorem? It doesn't prove it, Jun admitted. But it gives us a starting point. What if we develop a new mathematical language specifically designed to map these relationships? After much debate, the team agreed to try Jun's approach. They split the work, with each person focusing on different aspects of the new framework. Within a week, they had developed what they called shadow projection theory. It wasn't complete, but it showed promise. For the first time, they could work with 5D objects without needing to visualize them fully. Hana was particularly excited. This is exactly what I meant by finding the human way, she told Jun. We're using our understanding of relationships to overcome our perceptual limitations. News spread quickly through the Institute about the human's new approach. Most alien mathematicians dismissed it as primitive, but a few showed interest. One morning, Advisor Tal visited the human lab. The tall, glowing being observed silently as the team explained their work. Interesting, Tal said finally. You are not trying to see what you cannot see. Instead, you are building a framework to understand it through relationship patterns. Yes, Jun agreed. We believe this approach plays to human strengths. Tal's glow pulsed thoughtfully. The Axiom Collective has made significant progress using their natural 6D perception. But perhaps there is value in your alternative approach. After Tal left, Su-jin looked worried. The Axiom Collective is far ahead of us. They've been solving parts of the theorem that we haven't even approached yet. But they're using conventional methods, Jun argued. Our approach might let us skip several steps. As the weeks passed, the human team refined their theory. They created a hybrid mathematical language that combined traditional notation with new symbols representing dimensional relationships. Jun continued his late-night coffee meetings with Daho, often bouncing ideas off the practical-minded custodian. Though Daho couldn't follow the complex math, his simple questions often led Jun to new insights. Sometimes I think you understand this better than I do, Jun told him one night. Daho laughed. I just ask questions. You're the one finding answers. 1 month into the challenge, the Institute held a progress report meeting. Representatives from each species presented their work so far. The Axiom Collective went first. Their representative, a shimmering cloud-like being, displayed complex 5D models that most species couldn't fully comprehend. We have solved 40% of the theorem, the Axiom announced proudly. Our natural perception of 6 dimensions gives us a clear advantage. Other species presented their progress, each claiming between 15 and 30% completion. When it was the human's turn, Su-jin asked Jun to present. Jun stood nervously before the assembled beings. The human team has taken a different approach, he began. He explained their shadow projection theory, using simple examples to illustrate the concept. While we have only solved about 20% of the theorem, Jun concluded, our framework gives us a way to understand 5D relationships without needing to perceive all dimensions simultaneously. After the presentation, the Axiom representative approached Jun. An interesting toy model, it said, its voice like static electricity. But you cannot truly understand what you cannot perceive. I disagree, Jun replied calmly. Understanding doesn't require direct perception. It requires finding patterns and relationships. The axiom made a sound like crackling lightning, which Jun's translator didn't catch. Then it moved away, rejoining its collective. You handled that well, Hannah said, coming to stand beside him. Did I? I feel like I just made an enemy. Hannah smiled. The Axiom Collective doesn't think in terms of friends and enemies. They just think they're better than everyone else. As they entered the second month of work, the human team hit a problem. Their framework was sound in theory, but they needed more computing power to apply it to the full theorem. The alien teams have quantum computers designed for higher dimensional calculations, Hannah explained during a team meeting. Our standard equipment can't handle the complexity. Can we request better computers? Joan asked. Su-Jin shook her head. I already tried. There's a waiting list, and we're at the bottom because they don't think our approach will work anyway. The team fell into frustrated silence. Without more computing power, they couldn't move forward. That evening, Joan explained the problem to Daho during their coffee break. So you need better computers to solve all these equations? Daho asked. Yes, the calculations are too complex for our current systems, and we can't get better ones. Daho was quiet for a moment, folding another napkin as he thought. When I built houses, sometimes the power would go out. No electric tools, no computers for the architects. What did you do? Joan asked. We used our hands and our minds. Daho held up the folded napkin. Human brains are powerful computers too, just different. June started to say that human brains couldn't possibly handle the complex 5D calculations, but then stopped. Wait, what if we break the problem down differently? He pulled out his tablet and began typing rapidly. What if, instead of trying to compute everything at once, we divide the calculations into smaller parts that can be processed separately? Like how a house is built by many workers, each doing one job. Daho suggested. Exactly. June's excitement grew. We could create a distributed human computing system. Each person solves one part of the equation, then passes their result to the next person. That night, June couldn't sleep. He kept refining his idea for human-based distributed computing. By morning, he had a basic plan. He presented it to the team first thing. We don't need fancy quantum computers, he explained. We need coffee and teamwork. Su-Jin looked doubtful. You want us to do the calculations manually? That would take forever. Not if we work as a system, Jun argued. He showed them his plan for breaking down the 5D calculations into manageable 3D components the humans could process. Each person focuses on one aspect of the transformation. We work in shifts, passing our results to the next person. Together, we become a human quantum computer. The team debated the idea all morning. Some thought it was brilliant, others called it desperate. In the end, Su-Jin made the decision. We have no better options, she said. Let's try June's human computer. They set up what they jokingly called the coffee-powered computer in their lab. Each team member had a specific role, focusing on one aspect of the 5D calculations. They worked in 6-hour shifts with detailed handover procedures. The first day was chaotic. People made mistakes, calculations had to be redone, and progress was painfully slow. This will never work, one team member complained after a particularly frustrating shift. But Jun wouldn't give up. We just need to refine our process, he insisted. He spent that night with Daho, talking through the problems. Daho suggested organizing the work like a construction site, with clear roles and checkpoints. In building, we have inspections at key points to catch mistakes early, he explained. You need the same for your calculations. The next day, they reorganized their human computer with Daho's suggestions. Each calculation now had verification steps built in, and they created a visual system to track progress. Slowly, the system began to work. The humans processed 5D calculations through their network of minds, each person handling the parts they could visualize and passing along the results. Word spread through the Institute about the strange human approach. Some aliens came to observe, watching with a mixture of curiosity and disbelief as the humans passed equations back and forth, checking each other's work and gradually solving parts of the theorem that had stumped even advanced computers. It's slow, Hannah admitted when Advisor Tal came to observe. But it's working. Tal's glow pulsed with interest. You have turned your limitation into a different kind of strength. Fascinating. As the end of the second month approached, the human team had solved nearly 30% of the theorem, still behind the Axiom Collective, but gaining ground with their unconventional approach. "We might actually have a chance," Su-Jin said during a team meeting, surprising everyone with her optimism. June looked around at the tired but determined faces of his fellow humans. They had created something unique, a mathematical framework that allowed human minds to work with concepts beyond human perception. That night, as he sat with Daho in the quiet cafeteria, Jun felt a new confidence. "Thank you," he told the older man. "Your napkin started all of this." Daho smiled and folded yet another napkin into a complex shape. Sometimes the simplest things show us the way to understand the most complex ones. He held the folded napkin under the light, casting a shadow that seemed to change and move as he slowly rotated it. The universe is full of shadows from higher dimensions. All we need is the wisdom to read them. At the start of the third month, the atmosphere in the human lab had changed. What began as a desperate attempt had turned into a well-oiled system. The team had grown stronger, working together in their human-computer network. Jun sat at his desk, reviewing the latest results. They had now solved almost 40% of the theorem, still behind the Axiom Collective's 60%, but gaining ground every day. Hana walked in, carrying a tray of coffee cups. "Fuel for the human computer," she announced, setting the tray down. "Thank you," Jun said, taking the cup. "How's the new transformation matrix coming along?" "Almost done," Hana replied. "Minho is finalizing the calculations now. He should be finished by lunch." Minho Choi was the newest addition to their team, a quiet mathematician who had joined them 2 weeks ago. At first, he had been skeptical of their approach, but after seeing it in action, he became one of its strongest supporters. The door opened, and Su-Jin entered with a serious look on her face. "The director has called for a special progress meeting this afternoon. All teams must present their current work." June frowned. "That's not scheduled. Is something wrong?" "I don't know," Su-Jin admitted, "but rumor says the Axiom Collective has made a major breakthrough." The team exchanged worried glances. If the axioms had solved the theorem, all their work would be for nothing. "We need to prepare our presentation," Su-Jin continued. "June, can you and Minho get your latest results ready? Hana, work with the others to create visual models of our approach." Everyone nodded and got to work. The relaxed atmosphere from moments ago was replaced with tense focus. The great spherical chamber was packed with beings from all teams. June sat with the humans, trying to stay calm as the Axiom Collective representative floated to the center of the room. "Esteemed colleagues," the shimmering cloud being began, its voice transmitted directly to everyone's translators. "We have achieved a significant breakthrough in our work on the Penrose-Fex theorem." A complex holographic model appeared in the air, showing structures that hurt June's eyes to look at. The axiom manipulated the model, highlighting different sections. "We have solved 70% of the theorem," the axiom announced proudly. "Our natural perception of higher dimensions has allowed us to map the core structure. We predict complete solution within 2 weeks." Murmurs spread through the chamber. Most sounded impressed, though some teams seemed disappointed to be so far behind. Advisor Tell floated forward, its globe pulsing with interest. "Impressive work, Axiom. Are there aspects that still challenge you?" The Axiom's form rippled slightly. "The final sections involve unusual junction points between the 5th and 3rd dimensions. We are developing new approaches to resolve these." Jun straightened in his seat. Junction points between dimensions were exactly what their shadow projection theory was designed to handle. He leaned over to whisper to Su-Jin, "We might have an advantage there." Su-Jin nodded. "Let's see what they think of our progress." After several other teams presented, it was finally the humans' turn. Minho stood and walked to the center. As the youngest member, they had chosen him to present their newest findings. Minho cleared his throat, looking small in the vast chamber. "The human team has now solved 42% of the theorem," he began. A ripple of surprise moved through the audience. They had made more progress than most expected. Minho continued, explaining their shadow projection theory and how they had used their human computer to process complex calculations. While we can't naturally perceive 5 dimensions, he said, we've developed a framework that allows us to understand the relationships between dimensional projections. He displayed their models, showing how their approach mapped transformation patterns between dimensions. Our method is particularly effective for analyzing junction points, the places where dimensions intersect and interact, Minho explained. We believe this will give us an advantage in the final stages of the theorem. The axiom representative moved forward, its form flickering with what seemed like irritation. How can you claim to understand junction points when you cannot even perceive the dimensions they connect? It demanded. Minho stood his ground. Understanding doesn't always require direct perception. Think about radio waves. Humans can't see them, but we understand their properties well enough to build complex technologies around them. That is a primitive comparison, the axiom said dismissively. Is it? Minho challenged. Or is it proof that perception and understanding are different things? Perhaps your ability to see higher dimensions has limited your thinking in ways you don't realize. The chamber fell silent at this bold statement. The axiom's form pulsed rapidly, but before it could respond, Advisor Tal moved between them. An interesting perspective, Tal said. Let the results speak for themselves. We will have another meeting in 2 weeks to review final progress. As the meeting ended, teams broke into small groups, discussing what they had heard. Several alien mathematicians approached the human team, curious about their unusual approach. A tall, mantis-like being called Sith asked, "How did you develop this projection theory? It's unlike standard mathematical models." June explained their coffee-fueled late-night sessions and showed how Daho's folded napkins had inspired their breakthrough. Sith's compound eyes reflected the light as it considered this. So a non-mathematician helped solve one of the most complex mathematical problems in the galaxy. Fascinating. Sometimes the best insights come from unexpected places, Jun said. That evening, the human team celebrated their successful presentation with a small party in their lab. They had earned the respect of other teams and proven their approach had merit. June invited Daho to join them. The custodian seemed uncomfortable at first, but the team welcomed him warmly. Without your napkins, we wouldn't have our theory, Hannah told him, raising her coffee cup in toast. Daho smiled shyly. I just folded paper. You did the real work. That's not true, June insisted. Your practical perspective helped us see what our trained mathematical minds missed. As they celebrated, Advisor Tal unexpectedly visited their lab. The tall, glowing being looked around with interest at their makeshift party. I hope I'm not interrupting, Tal said. Not at all, Su-Jin assured the director. We're just celebrating our progress. Tal moved closer to their work area, studying the diagrams and equations covering the walls. Your approach is unusual, but effective. The Axiom Collective is concerned. They're still far ahead of us, Minho pointed out. In percentage solved, yes, Tal agreed. But they've reached a difficult section that resists their methods. Your theory about junction points may prove correct. June felt a surge of hope. We'll focus our efforts there, then. Tal's glow pulsed gently. I came to offer resources. Additional computing equipment has become available if you wish to use it. The team exchanged glances. After working so hard to develop their human computer system, would they abandon it for faster machines? Thank you, Su-Jin said carefully. But we found our method works well for us. The human computer forces us to break down problems in ways that reveal new insights. Tal seemed surprised but pleased. You choose to maintain your limitation when a solution is offered. It's not just a limitation anymore, June explained. It's become a strength. Our approach requires us to understand each step deeply, rather than relying on a machine to process it. After Tal left, the team discussed their decision. Had they made the right choice in refusing the additional computing power? I think we did, Hannah said. Our human approach is working. Let's stick with what's gotten us this far. The next 2 weeks were intense. The team refined their theory and focused on the junction points the Axiom Collective was struggling with. They worked in shifts around the clock, their human computer processing increasingly complex calculations. Daeho visited often, bringing coffee and snacks to fuel their work. Though he still didn't understand the mathematics, he could see when they were stuck and would offer simple questions that often led to new perspectives. One night, when they hit a particularly difficult section, Daeho watched them struggle for hours. Finally, he asked, "Have you tried turning it inside out?" "What do you mean?" Jun asked, rubbing his tired eyes. Daeho took a napkin and folded it into a simple shape. In carpentry, sometimes a joint won't fit no matter how you push it. But if you approach from the opposite direction, it slides right in. He demonstrated by unfolding the napkin and refolding it from a different starting point, creating the same final shape through a different sequence. Minho stared at the napkin. "Of course. We've been trying to map the 5D to 3D junction from the 5D perspective. What if we reverse it and map from 3D to 5D instead?" The team quickly reworked their equations using this reversed approach. To their amazement, the solution began to take shape more clearly. "It's like looking through the right end of a telescope," Hannah said excitedly. "Everything comes into focus." By the end of the week, they had solved nearly 60% of the theorem and were making rapid progress on the junction points. 3 days before the final deadline, Minho burst into the lab, his face glowing with excitement. "I think I've got it," he announced. "The final transformation pattern." The team gathered around as he explained his breakthrough. By combining their shadow projection theory with the reversed approach inspired by Daeho, Minho had found a way to resolve the most complex junction points in the theorem. "If this is right," Soo-jin said, checking his calculations, "we've solved almost the entire theorem." They worked through the night, verifying Minho's solution and applying it to the remaining sections. By morning, they had solved 85% of the Penrose-Fex theorem. The Axiom Collective reported 78% at yesterday's update. Hannah said, her voice filled with disbelief. "We're ahead of them." The news spread quickly through the institute. Aliens from other teams came to see the humans work, curious how they had surpassed the Axiom Collective. The axioms themselves sent representatives, their cloud-like forms darkened with what seemed like concern. They studied the humans' equations and models carefully. "Your method is unorthodox," one axiom admitted reluctantly, "but effective for these junction points." Jun felt a surge of pride. Their human approach, born from napkins and coffee and limited perception, had proven superior to the axiom's natural advantages. On the final day before the deadline, the human team made their last push. They worked continuously, passing calculations through their human computer network, each person contributing their piece to the whole. As the deadline approached, Soo-jin verified their final results. 97%, she announced. "We've solved 97% of the theorem." The lab erupted in cheers. Even if they hadn't solved the entire theorem, they had achieved far more than anyone thought possible. Advisor Tal arrived just before the deadline. The tall being's glow was bright with excitement as it reviewed their work. "Remarkable," Tal said. "You've created a new mathematical framework that makes 5-dimensional topology accessible to 3-dimensional minds." "Not completely solved, though," Jun admitted. "There's still 3% we couldn't resolve." Tal's glow pulsed gently. "The Axiom Collective reports 92% completion. You have exceeded their progress." The team looked at each other in stunned silence. They had beaten the axioms. "How did they get stuck?" Minho asked. "The same junction points that you solved," Tal explained. "Their natural perception became a limitation. They couldn't conceptualize the transitions in a way that fit the theorem." "And our final 3%?" Soo-jin asked. "Perhaps it will require a different perspective altogether," Tal suggested. "But you have proven something important today. Perception and understanding are not the same thing." Sometimes, working around a limitation creates greater insight than having a natural advantage. As Tal left, the exhausted team looked around at their lab. Walls covered with equations, napkins folded into strange shapes, empty coffee cups everywhere. Their messy, human approach had accomplished what seemed impossible. "We did it," Hannah said softly. "We found the human way." June nodded, thinking of how far they had come. From feeling inferior because they couldn't see in 5 dimensions, they had developed a method that would change mathematics across the galaxy. That night, he found Daho in the cafeteria. The custodian was carefully folding a stack of napkins into complex shapes. "I heard the news," Daho said, smiling. "Congratulations. We couldn't have done it without you," Jun told him sincerely. "Your napkins changed everything." Daho shook his head modestly. "I just fold paper. You saw what it meant." Jun poured them both coffee. "The final presentation is tomorrow. Will you come? You deserve recognition for your contribution." "I don't need recognition," Daho said quietly. "But I'll come to support you." As they sat together, Jun realized how much had changed. They had come to the Institute feeling limited by their human perception. Now they understood that sometimes limitations could become strengths, forcing you to find creative solutions that those with natural advantages might never discover. The human approach, messy, collaborative, innovative, had proven itself against the greatest minds in the galaxy. They hadn't just solved a theorem. They had shown a new way of thinking that could change how the galaxy approached problems. And it had all started with coffee and napkins. The day of the final presentation arrived. The great spherical chamber was filled beyond capacity. Beings from all across the Institute had come to witness the results of the Penrose-Vex Theorem Challenge. June stood with the human team near the front, trying to stay calm. Daho sat a few rows behind them, looking uncomfortable in formal clothes instead of his custodian uniform. Advisor Tell floated to the center of the chamber, its glow bright and steady. The room fell silent. "Today marks a historic moment for the Galactic Research Institute," Tell began. "For centuries, the Penrose-Vex theorem has resisted our greatest minds. Now, we stand at the threshold of a solution." Tell gestured to a display showing the final standings. 3 teams have achieved remarkable progress. The Diraxian mathematicians have solved 78%. The Axiom Collective has solved 92%. The Axiom representatives pulsed with pride, clearly expecting to be named the winners despite not reaching a complete solution. And the human team, Tal continued, has solved 97%. A wave of murmurs swept through the chamber. Many eyes turned toward the human group with surprise and new respect. More importantly, Tal added, "The human approach has created an entirely new mathematical framework that makes 5-dimensional topology accessible to 3-dimensional minds. This achievement may prove more valuable than a complete solution using conventional methods." The Axiom representative floated forward, its cloud form darkened. "With respect, Director, the challenge was to solve the theorem, not create alternative frameworks. The humans have not provided a complete solution. Neither has any other team," Tal pointed out calmly. "And the human approach has solved sections that resisted all other methods." The Axiom pulsed rapidly. "Their solution is unverified. How can we be certain their methods are sound when they cannot even perceive the dimensions they claim to understand?" "A fair question," Tal agreed. "Which is why we will now verify the human solution before making a final determination." Tell announced the formation of a verification committee with mathematicians from 7 different species, including 1 axiom. They would spend the day reviewing the humans' work in detail. As the committee left with the human team's full documentation, Su Jin turned to her colleagues. "This could go either way. The axioms will look for any flaw they can find." "Our work is solid," Minho insisted. "They'll see that once they study it properly." June wasn't so confident. "But will they understand our approach? It's so different from conventional methods." Hana put a reassuring hand on his shoulder. "That's why Tal included experts from multiple species. Come on, let's get some coffee while we wait. The verification process took all day. The human team waited anxiously in their lab, unable to focus on anything else. Daeho joined them, folding napkins into increasingly complex shapes to help pass the time. No matter what happens, he told them, you've already accomplished something remarkable. You showed the galaxy a new way of thinking. Finally, late in the evening, they received a message to return to the chamber. The committee had finished their review. The room was just as full as before, with beings murmuring excitedly as the humans entered. June could feel countless eyes watching them as they took their places. Advisor Tull floated to the center, accompanied by the 7 committee members. The Axiom representative was noticeably absent from this group, replaced by a different member of their collective. The verification committee has completed their review, Tull announced. I will let them share their findings. A tall, insect-like being stepped forward. We have examined the human solution in detail. It began, its voice clicking through the translators. Our conclusion is unanimous. The chamber fell completely silent. June held his breath. The human approach is not only mathematically sound but represents a breakthrough in dimensional topology. Their shadow projection theory solves 97% of the Penrose-Fex theorem through methods that are rigorous, innovative, and extraordinarily elegant. Relief and joy washed over June. They had done it. Their work was verified. More significantly, the committee member continued, the human framework offers a new approach to understanding higher dimensional mathematics that does not require higher dimensional perception. This may prove revolutionary for fields beyond this single theorem. Another committee member, a floating crystalline structure, moved forward. We have also determined the reason for the final 3% that remains unsolved. It appears to involve a type of dimensional folding that requires combining aspects of both the human approach and the Axiom Collective's work. Neither team could solve it alone because each was missing insights the other had developed. Tal's glow brightened. Then perhaps cooperation rather than competition will complete the theorem. But today, we recognize the human team as the winners of this challenge. The chamber erupted in sounds of approval and excitement from most species. The Axiom representatives pulsed with darker colors, but remained silent. Would the human team please come forward? Tull requested. Su Jin led the team to the center of the chamber. June glanced back and motioned for Daeho to join them. The custodian shook his head, but Minho went to him and practically pulled him forward. The human team has not only solved an impossible problem, Tull announced. They have demonstrated that perception and understanding are not the same thing. This is the true revelation of their work. Tail turned to the humans. As promised, Earth will receive triple research funding for the next 50 years. Additionally, the Institute will establish a new department dedicated to perceptual limitation theory, studying how different forms of perception influence mathematical and scientific understanding. Su Jin stepped forward. On behalf of the human team and Earth, we are honored. But we must acknowledge that our breakthrough came not just from professional mathematicians, but from unexpected sources. She gestured to Daeho, who looked uncomfortable with the attention. Daeho Lee is not a mathematician. He's a custodian and former carpenter whose practical insights were crucial to our approach. Without his folded napkins and simple questions, we would never have developed our theory. Murmurs of surprise spread through the crowd. A custodian had helped solve one of the galaxy's greatest mathematical puzzles. This is the true strength of humanity. Su Jin continued. We overcome our limitations by bringing together different perspectives and finding connections between ideas that seem unrelated. Tail floated closer to Daeho. The Institute has always valued knowledge from all sources, but perhaps we have become too focused on traditional expertise. Your contribution reminds us that wisdom can come from unexpected places. After the ceremony, the chamber gradually emptied as beings returned to their labs and living quarters. Many stopped to congratulate the human team, expressing interest in learning more about their approach. To June's surprise, a representative from the Axiom Collective approached them. Its cloud form was lighter now, pulsing with gentler colors. "The axiom acknowledges the value of your method," it said formally. "We request collaboration on the final 3% of the theorem." Sujin nodded. "We would be honored to work with you." "Perhaps," the axiom suggested, "we might begin with a demonstration of these napkin folds that inspired your breakthrough." Daeho stepped forward with a small smile. "I would be happy to show you." 3 months later, the Galactic Research Institute announced the complete solution to the Penrose-Fex theorem. The human team and the Axiom Collective had worked together, combining their approaches to solve the final sections. The solution led to immediate advances in faster-than-light travel, interdimensional communications, and energy generation. But more importantly, it changed how species across the galaxy approached problems. The new Department of Perceptual Limitation Theory, with Jun as its director and Daeho as a special advisor, became one of the most popular at the Institute. Beings from all species came to study how different perceptual limitations could lead to unique insights and approaches. One morning, Jun walked into the department's main lab to find aliens of various species sitting at tables, folding napkins, and drinking coffee. Some had 8 limbs, some had none at all, some floated above their seats, but all were trying to understand the human approach to mathematics. "It's become quite popular," Hannah said, joining him at the door. "Even the axioms have started drinking coffee. They say it helps them think in more limited ways." "I'm not sure Daeho expected to start a galactic trend with his napkin folding," Jun laughed. "Speaking of Daeho, he's giving a lecture today on practical insight in theoretical problems. Every seat is taken." Jun smiled. "From custodian to lecturer in 3 months. That might be an even bigger breakthrough than our theorem." They walked through the lab, observing as aliens struggled with concepts that came naturally to humans, working around limitations, using physical models to understand abstract ideas, approaching problems from unlikely angles. "It's strange," Jun reflected. "For so long, we felt inferior because we couldn't perceive higher dimensions. Now they're all trying to think like us." "That's because they finally understand what we've always known," Hannah replied. "Limitations breed innovation. When you can't see the direct path, you find new roads that might be better." In the corner of the lab, a small group of researchers from 7 different species worked together on a new problem, each bringing their unique perceptual framework to the challenge. They passed napkins back and forth, drawing diagrams and folding them into shapes that represented concepts beyond any single species' perception. "Look at them," Jun said, "each limited in their own way, but stronger together." "That's the real solution we found," Hannah agreed, "not just to the theorem, but to the galaxy's approach to knowledge." 1 year after the challenge ended, the Institute held a ceremony to unveil the first ship equipped with engines based on the completed Penrose-Fex theorem. The vessel could travel between galaxies in days rather than the centuries it would have taken before. As guests gathered for the ceremony, Jun found Daeho standing quietly near the back, watching the proceedings with a modest smile. "They're naming a principle after you," Jun told him. "The Lee perspective, approaching higher dimensional problems through lower dimensional analogies." Daeho looked embarrassed. "I just folded napkins and changed how the galaxy approaches mathematics," Jun added. "Not bad for a custodian." "Former custodian," Daeho corrected with a smile. "Now I just fold napkins professionally." They watched as Advisor Tull presented the new ship, explaining how the human approach to 5-dimensional math had made it possible. "You know what still amazes me?" Daeho said quietly. "Those species that can naturally see in higher dimensions spent centuries trying to solve the theorem. Then humans who can't see what they're working with solve it in a few months. Because we had to find a different way," Jun explained. "When you can't see something directly, you have to build a bridge to understanding it." Across the room, Jun noticed a group of young aliens watching Daeho with admiration. They each held folded napkins, carefully studying the patterns. "You have fans," Jun noted, nodding toward them. Daeho laughed. "They think there's some secret to the napkin folding. I keep telling them the secret isn't in the napkins. It's in asking simple questions about complex problems. After the ceremony, they joined Hana, Sujin, Minho, and the rest of the team in the cafeteria, the same place where it had all started a year ago, with late-night coffee and folded napkins. The cafeteria was now a popular gathering spot for beings from all species. Tables were full of mathematicians and scientists, many with coffee cups and paper napkins, all trying to see problems from new angles. I heard the Diraxian Mathematics Council is changing their entire approach to education. Sujin told the group. They're now teaching students to artificially limit their perception to force more creative problem solving. And 3 more species have requested human mathematicians as advisors, Hana added. Apparently, our perceptual limitations are now considered valuable. June smiled at the irony. What had once made humans feel inferior in the galactic community had become their greatest contribution. Minho raised his coffee cup. To seeing what cannot be seen. To understanding what we cannot perceive, Hana added. To napkins and coffee, Daho said with a grin. They all laughed and raised their cups. Around them, beings from across the galaxy were learning what humans had always known. That limitations could be the beginning of innovation, not the end of it. As June looked around the cafeteria full of aliens trying to think more like humans, he remembered something Daho had said during those first late-night sessions. Humanity's greatest strength isn't seeing what's there, he had said, folding a simple napkin into something complex and beautiful. It's imagining what isn't. And now, that human gift for imagination had opened up the galaxy in ways no one could have foreseen. Not bad for a species that could only see in 3 dimensions.